The problem is add 2 first. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given two arrays A and B, both are of size n. We can perform the following operation in A. We'll choose some integer x and then we'll choose the smallest index I such that the element in A at this index is greater than or equal to x. If no such index exists, we will do nothing. Once we have found this index, we'll update it or increment it by 1. We need to check whether it is possible to go from A to B. Let's see the input format. We have t test cases, and for each test case, we have 3 lines. The first line contains the integer n. The second line contains n space integers, that is our array A, that is A1, A2 till An. And third line similarly contains the array B, B1, B2 till Bn. As for the output, we simply have to output yes or no to confirm whether it is possible to convert array A to array B. As for the constraints, number of test cases will go from 1 to 10 raised to 4, length of the array will go from 1 to 2 into 10 raised to 5, and the elements in the arrays will go from 1 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, the array A has the elements 1, 2 and 2, and array B has the elements 1, 3 and 2. We start from the leftmost index. At the first index, both the elements are already same, so we have nothing to do. On the second index, we can see that the element in array A is less than the element in array B. So what we'll do is, we'll choose x as 2. If we do this, now we need to find the smallest index that is greater than or equal to 2. That luckily happens to be this index. Therefore, we can perform the operation on this and increment it by 1, by which this becomes same, and the last index is also same. Therefore, both the arrays A and B have become equal. Therefore, the answer is yes. Let's see the second sample input. This is nothing but a little bit of variation of the first sample input that we have seen. Array B is 1, 2, 3 and array A is 1, 2, 2. Similar to what we have in the first sample input, but a little bit different. The first index is still the same. The second is also same. The third, again, the element in A is less than element in B. Now, we might be tempted to again choose x as 2. But now if we do this, again, the smallest index that is greater than or equal to 2 is this index. So if we perform the operation, this element will be updated, not the one that we want. Therefore, it is not possible to increase this. Because if we choose a number greater than this, then no index will be selected. And if we choose anything equal to or less than this, again, nothing will be selected here. Therefore, the answer still is no. Let's see how we can approach the solution. So the operation that we can perform only increments the element that we have. So let's say if we have a case where element in A is greater than element in B, the answer is straightforward no. Because we don't have any operation that will decrease the value of element in array A. Now that this is out of the picture, we have the condition left with us that it is either less or equal to the element present in B. Now if it is equal, again, we have nothing to do. If AI is equal to BI, we simply move forward. Now the case that we are left with is that AI is less than the element BI. Now in this case, what we need to do is we need to choose a value of x, and then we will choose a index I in such a way that this index has an element that is greater than or equal to x. Now let's say we choose the element, we are at AI, right? Let's say we choose the element that is greater than AI. If that is the case, then we are never going to be able to choose this index. That is done, right? What if we choose something less? If we choose something less, then it might be possible, but there's also a probability that something smaller already exists. So we are forced to choose an element that is equal. So if we choose the x to be equal to AI, then we can perform the operation as we have seen here in the very first sample input. Now what happens if we have an element that is already greater than this? So let's say we have element 4 here and we have an element 3 here. This is array A and this is array B. Now, at first glance, it might look easy that we can simply choose x as 3 and update this to become 4. But that will not be possible because if you remember the condition is for element of index to be greater than or equal to x. In this case, this 4 also satisfies that condition. So with this, we need also to make sure that while we are traversing the array from left to right, we have not encountered an element that is greater than what we are trying to change. If that is the case, then again the answer would be no. So if it is equal, it is good. If it is great, the answer is no. But if it is less, and additionally, the element that we are traversing with, right, it is less than equal to the maximum that we have seen, again the answer would be no. But if we somehow go over all of these conditions and we are still not reached no, then our answer would be yes, because in that case we can keep on performing the operation and make array A to be equal to array B, and then we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and our arrays A and B. Once we have this, we initialize our answer is yes and our maximum value as 0. Then we start going over each index from the leftmost index, that is 0. If the element that we have in A is greater than the element in B, the answer is straightforward no. If that is not the case and the element array in A is less than the element in B, then we need to check that this element is actually greater, greater than the maximum or the other numbers that we have seen before this. So if that is not the case, again our answer would be no. Then we update our maximum with what we have seen till now. We keep on doing this, and if we survive all the indices without getting no as an answer, then at the end the answer would be yes. Otherwise it will be no. Whatever it might be, we print the solution or the answer at the end, and as you can see, I have AC in my C++ implementation. Let's see how we can do this in Python. Again, for each test case, we call the function solve, take the input of n and our array A and B. We initialize the result as yes and our maximum as 0. We go over each index, and if the element in A is greater than element in B, the answer is no. If it is less, but it is also less than some of the previous numbers that we have seen, or it is less than the maximum from the previous that we have seen, the answer would again be no. If we survive all the indices, the answer would be yes. And as you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.